What if the very first ingredients for life didn't form on Earth at all, but were delivered here by comets already partially assembled in the icy darkness of deep space? In a stunning leap for astrochemistry, scientists have uncovered a molecular treasure trove around a young star named V883 Orionis. Located 1,350 light-years away in the Orion constellation, this infant star is encircled by a swirling protoplanetary disk of gas, dust, and ice. Exactly the kind of environment where planets and possibly life take shape. The real surprise? Within that disk, researchers detected 17 complex organic molecules, some never previously observed in such settings. Among them were ethylene glycol, the same compound used in antifreeze, and glycolonitrile, closely related to essential components of DNA and amino acids. These aren't just exotic molecules, they're fundamental steps on the path toward life. And for the first time, they've been found not in distant clouds or ancient meteorites, but in a newborn star system. This discovery challenges one of astronomy's long-standing assumptions, the reset hypothesis. According to that theory, the violent emergence of a star annihilates complex molecules formed earlier, wiping the chemical slate clean. Any life-related compounds would need to reassemble in the aftermath amid chaotic rubble and intense radiation. But V883 Orionis tells a different story. Instead of obliterating these organics, the transition from cold interstellar cloud to fiery young star seems to preserve and perhaps even amplify them. Scientists now suggest that there's a continuous chemical thread stretching from early star-forming clouds to mature planetary systems. The implication? Life's raw ingredients might be universal, seeded throughout space as part of the natural evolution of stars. That didn't come without effort. The breakthrough was made possible by the Atacama Large Millimeter Submillimeter Array, ALMA, high in Chile's desert. This observatory's precise antennas can pick up the faint signals emitted by molecules at millimeter wavelengths, especially as they warm up near young stars like V883 Orionis. Here's where it gets fascinating. V883 Orionis is still pulling in gas from its surrounding disk. These episodes of rapid growth unleash intense energy bursts that heat the disk. As temperatures rise, ices melt, and molecules trapped within them evaporate into gas, broadcasting their spectral signatures, signals that ALMA is perfectly tuned to capture. The results were striking. A vibrant mix of organic compounds, ethylene glycol, glycolonitrile, methanol acetaldehyde, each one a tiny rung on the biochemical ladder. If they're abundant in a system this young, could they be common throughout the galaxy? Every time a star is born in a nebula, it may already come equipped with a molecular toolkit capable of sparking life. Far from rare anomalies, these molecules could be standard features of cosmic evolution. Our own solar system backs this up. Ancient meteorites have been found to contain amino acids, sugars, and nucleobases, the molecular letters of life. Comets, those frozen remnants from our system's birth, preserve similar chemistries. As they near the sun and heat up, they release gases that glow, revealing their molecular contents, sometimes even sampled directly by spacecraft. This consistency points to a profound truth. If Earth's life arose from such space-borne compounds, similar scenarios might unfold across the universe, on icy moons, in hidden oceans, or on rocky worlds orbiting distant suns. Some molecules near V883 Orionis, like glycolonitrile, are just one reaction away from forming simple amino acids like glycine and alanine. Others are closely linked to adenine, a building block of both DNA and RNA. It's as if the universe is writing the same recipe for life again and again in interstellar clouds, planetary disks, comets, and rocks. This rewrites our understanding of life's chemical timeline. Scientists once believed that complex organics could only emerge under specific, planet-based conditions over millions of years. But V883 Orionis suggests otherwise. Space itself appears capable of assembling life's ingredients long before any planet forms. And this could just be the beginning. The current detections, though groundbreaking, may only hint at a deeper molecular complexity. The data from V883 Orionis are still being examined. Future high-resolution studies may uncover even more sophisticated compounds, perhaps full amino acids. Meanwhile, next-generation telescopes will peer into other young systems, expanding the search. So next time you gaze up at Orion's belt, imagine what's unfolding inside those stellar nurseries. Molecules coalescing, chemistry evolving, the seeds of life already in motion. Because life doesn't start on a planet. It starts in a cloud, sculpted by radiation and time, etched into ice and carried across the galaxy, written in a molecular script as old as the stars themselves.
Imagine this. A sleek spacecraft lands back on Earth, carrying with it tiny pieces of rock and dust from the surface of Mars. Inside those rocks, frozen in time, could be the greatest discovery in human history, or the biggest threat. We've seen it all before in sci-fi. Aliens hiding in plain sight, taking over our bodies, our minds, our world. From the eerie replacement of humans in Invasion of the Body Snatchers, to the grotesque shapeshifter of The Thing, fiction loves to terrify us with stories of life from beyond. But let's be honest, nobody really believes an alien's gonna crawl out of a pod and eat your face. But what if the real threat isn't something big and monstrous? What if it's microscopic, silent, invisible, and real? In the next decade, humanity is planning something extraordinary. A mission to Mars will not just explore, it will bring pieces of the red planet back home. NASA and ESA are already preparing for the Mars sample return mission. It sounds like a huge leap forward in space exploration, and it is. But with it comes a question that scientists are only beginning to wrestle with. What if something is alive in those samples? And no, we're not talking about Martian octopuses or intelligent civilizations. We're talking about microbes, bacteria-like organisms that could have survived for millions, even billions of years beneath the Martian surface. If they exist, and if we're not careful, they could interact with our biosphere in unpredictable ways. That's why scientists around the world are racing against the clock to figure out how to detect life in Martian rocks without destroying the precious material in the process. Because here's the catch. Once we bring Mars samples back to Earth, we won't get a second shot. These fragments of another world are irreplaceable. Enter Yohei Suzuki, an associate professor at the University of Tokyo, and his team. They've developed a cutting-edge method that could change everything. It's called optical photothermal infrared spectroscopy, or OPTIR for short, and it can detect signs of microbial life in rock samples without grinding them into dust. Let's break this down. Traditional methods, like electron microscopy or nanosims, can reveal microscopic life, but they usually destroy the sample in the process. Not ideal when you're working with a rock that traveled 300 million kilometers to get here. OPTIR, on the other hand, only requires a thin slice of the sample, about 100 micrometers thick, and leaves the rest untouched. It's like giving a biopsy to a rock without killing the patient. What's more, the resolution of this technique is insanely precise, down to 0.5 microns. That's small enough to detect microbial cells and even distinguish between different types of biological molecules, like proteins. In tests using Earth rocks that are 100 million years old, Suzuki's team was able to identify microbial life still locked inside clay-filled fractures. These aren't just guesses or blurry images. The spectral fingerprints they captured, patterns of light and heat, match known biological signatures. It's like finding a fossil, but on a molecular level. But wait, it gets even better. The rocks they used as Martian analogs weren't chosen at random. They specifically selected basalt, a type of volcanic rock common on both Earth and Mars. In fact, the Perseverance rover has already collected basalt samples from the Jezero crater, and those are the very samples expected to return to Earth. Suzuki and his team are essentially rehearsing with Earth stand-ins before the real show begins. So what does this mean for us? It means we're on the brink of possibly answering one of the most profound questions in human history. Are we alone in the universe? Are we alone in the universe? Are we alone in the universe? But it also means we have to proceed with incredible caution. The organization overseeing planetary protection, COSPAR, has classified this as a Category 5 restricted Earth return mission. That's as serious as it gets. It means that the samples must be sealed, sterilized if needed, and analyzed using only the most advanced, non-destructive techniques available. The goal? To reduce the risk of accidentally releasing an alien microbe into Earth's environment to 1 in a million. That's right, scientists are literally working to make sure that the odds of missing a living organism, if it's in there, are less than 1 in a million. So while the movies like to show aliens crashing into Earth in a ball of fire, the real invasion, if it happens, might arrive in a test tube under tight quarantine, escorted by men in hazmat suits. And yet, that test tube could hold the answer to everything. Life on Mars. A second Genesis. Proof that Earth isn't the only cradle of biology in the cosmos. For now, it's a waiting game. Scientists continue to refine their instruments. Engineers prepare the containment systems. And somewhere, millions of kilometers away, little pieces of Mars are waiting to come home. And when they do, we'll be ready. We hope.
An invisible star, a red dwarf, hides 124 light-years away from us. And orbiting this faint celestial body is a planet that could fundamentally alter our understanding of life in the universe. Its name is K2-18b, and this is not its first time in the scientific spotlight. But now the reasons are far more compelling and perhaps historic. A team of astrophysicists from Cambridge, working with data from NASA's ultra-sensitive James Webb Space Telescope, has discovered chemical compounds in the planet's atmosphere that, on Earth, are produced exclusively by living organisms. The substances in question are dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. On our planet, these gases are typically associated with marine plankton and certain bacteria. What they are doing in the skies of a distant exoplanet is still a mystery, but a mystery that might point toward extraterrestrial life. Professor Niku Madhusudan, the lead researcher on the project, calls this the most convincing evidence to date of potential life beyond Earth. If our interpretation is correct, he says, we could confirm it within a year or two. Perhaps the most astonishing part of the discovery is the quantity. The concentration of DMS found in the atmosphere of K2-18b appears to be thousands of times higher than equivalent levels on Earth. If this is not a mistake or observational artifact, we may be looking at an entire world teeming with life. But scientists, including Madhusudan's own team, urge caution. The current data, while impressive, still falls short of the rigorous standards required for a formal scientific discovery. To claim definitive proof, they need a statistical confidence level of 99.9999%, known as the 5 sigma threshold. At present, the result stands at 3 sigma, or 99.7%, a significant improvement from previous estimates of 68%, but still not enough. Other researchers and independent experts echo the cautious tone. Astronomer Catherine Hamans, for instance, emphasizes that even with reliable data, we cannot say with absolute certainty that DMS and DMDS originate from biological processes. The universe is vast and filled with exotic phenomena. We still don't fully understand what can happen inside such alien worlds. The intrigue surrounding K2-18b isn't based solely on its mysterious chemistry. The planet is roughly 2.6 times the size of Earth, and data suggests it has an atmosphere where ammonia is notably absent, a gas that should be present in a dry, oceanless world. This absence points to a compelling hypothesis: the presence of a vast subsurface ocean. And where there's water, the possibility of life follows. However, alternative scenarios remain. The ocean might consist not of water, but of magma, a revelation that would crush hopes for life. Adding complexity, the planet's very structure is under debate. Some models describe K2-18b as a mini-gas giant with no solid surface. That would render the world utterly inhospitable to life, at least any form of life we currently comprehend. Still, despite all the ifs and buts, the scientific community remains deeply intrigued. The Cambridge team is collaborating with other research institutions to investigate whether the detected molecules could be synthesized through non-biological means in laboratory settings. If such synthesis proves impossible, the case for a biological origin becomes far stronger. Professor Subir Sarkar, another member of the project, is careful with his conclusions, yet he acknowledges that the possible presence of an ocean makes K2-18b one of the most promising candidates in the quest for alien life. His message is simple and clear. Watch this space. Cambridge astrophysicist Oliver Shortall, however, brings us back to reality. He reminds us that all of our knowledge about distant exoplanets is drawn from faint threads of light passing through their atmospheres. Interpreting those signals is like trying to read a smudged and half-burnt map, prone to error, to bias, to misinterpretation. Each promising signal could be either a whisper of life or a trick of the cosmic light. Yet the implications are impossible to ignore. Even the slightest probability of a biological origin for these gases elevates the conversation. This isn't just about chemistry. It's about existence. About the possibility that we may not be the only ones looking up into the void. Public curiosity has surged alongside scientific interest. News of K2-18b's chemical profile has lit up headlines, podcasts, classrooms, and conspiracy forums alike. Some hail it as our first real evidence of alien life. Others urge restraint, cautioning against the seduction of sensationalism. But in a world starved for wonder, K2-18b delivers, even if only as a promise. Further missions are already being drafted. Telescopes in space and observatories on Earth are preparing to lock their gaze on this distant enigma. New instruments, refined spectrographs, and smarter algorithms will seek to strip away more layers of the mystery. Every spectrographic fingerprint, every spectral dip in starlight brings us a little closer to confirmation, or recalibration. Science moves not with leaps of faith, but with patient, deliberate steps. And yet, some steps feel bigger than others. When we look at K2-18b, we don't just see another planet. We see a question written across the stars. Are we alone? As Madhusudan puts it, decades from now, we may look back at this moment and realize it was the beginning. The dawn of a new cosmic chapter. The moment humanity first saw the glimmer of a living universe beyond the solar system. The discovery hasn't been made yet, but the journey has begun, and that alone is already extraordinary.
Aliens might already be out there, and the next generation of space telescopes could actually see them. Not in flying saucers or shadowy silhouettes against the stars, but in the faint, twisted glow of polarized light bouncing off an alien ocean, or in the ghostly signature of molecules that twist in only one direction, the same quirky habit that all life on Earth shares. And the key to unlocking this interstellar mystery, a telescope so advanced, so precise, it could detect life not by accident, but by design. It's called the Habitable Worlds Observatory, and it's humanity's most serious attempt yet to answer the oldest question: are we alone? At first glance, the HWO might look like just another ambitious piece of NASA's long pipeline of missions, one more telescope among many. But make no mistake, this one is different. It's not built to study galaxies or unravel black holes. Its sole purpose is to find life. Not just planets that could be habitable, but worlds that are inhabited, teeming, thriving, alien ecosystems hundreds of trillions of kilometers away. Getting there, though, is like trying to solve a cosmic crime scene. You can't just zoom in and take a picture of the alien equivalent of a rainforest. You need evidence, layers of it. And the HWO is being designed to collect that evidence with surgical precision. Its mission unfolds in 4 stages, each one peeling back a layer of the unknown. First, identify potentially habitable exoplanets. That alone is no small feat. You're looking for tiny, dim specks of light next to the blinding blaze of their parent stars. But HWO is equipped with a built-in coronagraph, a kind of cosmic sunshade that blocks the overwhelming glare of the star, letting the light from the orbiting planet shine through. Second, look for the hallmarks of life. The most immediate clue? Color. Specifically, biopigments, substances like chlorophyll that reflect and absorb light in particular ways. These signatures show up in polarized light, which vibrates in specific directions. HWO's polarimeter is designed to detect those subtle twists and turns in light. revealing whether a distant world might be cloaked in alien greenery. But even that isn't proof. So the third step is to map the planet's surface, not in high definition, but enough to distinguish continents from oceans, clouds from deserts, and, just maybe, forests from barren rock. Variations in brightness, reflected light, and spectral fingerprints help sketch out a rough global map. Such mapping, though crude, could be the first time humanity ever sees an alien landscape. And then comes the final, breathtaking step, searching for chirality. Life on Earth exclusively uses molecules that are handed, either left-handed or right-handed, but never both. This asymmetry, called homochirality, is a universal trait of biological systems. And astonishingly, it leaves a telltale signature in circularly polarized light, a kind of light that spirals as it travels. Circular polarization is rare in nature, and its biological origins make it stand out like a flare in the darkness. If HWO detects it, we'll be able to trace the fingerprints of alien life without ever stepping foot on that distant planet. Unlike atmospheric gases that can be formed by volcanoes or other geological activity, chirality is incredibly hard to fake. But here's the real challenge. The signal would be faint. Only about 0.1% of the total spectrum, hidden among noise, distortions, and the glare of nearby stars. But HWO's instruments are being engineered to catch it, to sift the whisper of life from the cosmic static. And it's not alone in the hunt. Telescopes like JWST and upcoming ground-based observatories are already scanning the skies, identifying exoplanets that sit within the so-called habitable zones of their stars, regions where conditions might allow liquid water to exist. These discoveries provide the target list. HWO brings the forensic tools. The mission scope goes beyond mere detection. It also aims to characterize these distant environments in detail. How much of the planet is covered by water or cloud, what kind of atmosphere it has, whether there's seasonal variation. These insights would shape how we think about habitability itself, perhaps even redefining what we consider Earth-like. This isn't sci-fi fantasy. The concept is backed by real hardware plans and international support. The Astro 2020 Decadal Survey prioritized HWO as a flagship mission, recognizing its transformative potential. It's a long-term investment, a decade-spanning project that may define the course of space exploration for the rest of the century. Of course, $10 billion is a towering sum, but so is the cost of Hubble and James Webb, and no one today questions the value of those instruments, which revolutionized our view of the cosmos. HWO could be the next step in that legacy, not just expanding our knowledge, but changing our place in the universe. The implications are staggering. Discovering a planet with biosignatures would change science, religion, philosophy, everything. It would force us to rethink life itself. Are we a fluke or one instance of a cosmic pattern? And what if we find nothing? That answer too is monumental. If life is rare, if Earth is truly exceptional, it places a responsibility on us to preserve what we have, because it may be all there is. One way or another, HWO promises to break new ground. It's not about flashy visuals or viral headlines. It's about deep, deliberate science, about asking the hardest questions and building the tools to answer them. When that glimmer of twisted light finally reaches us, it won't just illuminate a distant planet. It will illuminate ourselves.
Brace yourself. We might be living in a ginormous black hole. The James Webb Space Telescope has been sending back some pretty crazy stuff. It has looked at a bunch of really faraway galaxies, those super old ones from the early universe. And guess what? Most of them are spinning in the same direction. To be precise, around 2/3 spin clockwise, and only 1/3 spin the other way. But if the universe was totally random, you'd expect it to be 50-50, half going one way, half the other. and that's not what's happening. So now, some scientists are wondering if this means the universe isn't as random as we thought. And there's also this wild theory that everything we see might actually be inside a giant black hole. Now, scientists aren't totally sure why this is happening, but there are two main ideas floating around. One possible explanation is that the universe was actually born spinning. The most shocking thing here is that his idea lines up with a theory called black hole cosmology, aka Schwarzschild cosmology, which basically says that our entire universe might be sitting inside a giant black hole. Like, we could literally be living in the middle of one, hidden inside a much bigger parent universe. This idea was first brought up when some smart folks noticed that the edge of a black hole, called the event horizon, aka the point where not even light can escape, might actually line up with the edge of our observable universe. So, the horizon we see when we look into space could be the same kind of boundary as the one surrounding a black hole. If that's true, then every black hole in our universe could actually be hiding a whole other universe inside it, a so-called baby universe. We just can't see or reach them because of that same event horizon. It's like a one-way door. Stuff can go in, but no info or light can come out. And even if something is happening inside, it remains completely invisible to us. So instead of the Big Bang starting from nothing, maybe it came from inside a black hole in another universe. When a massive star dies, its core collapses and forms a black hole. Normally, we think everything gets crushed into a super tiny point called a singularity. But there's another theory. When things get that dense, something called torsion, which is a twist caused by spinning particles, kicks in. And when that twisting force gets strong enough, it stops the collapse and causes a massive bounce. A similar bounce might have started our universe. The insane gravity at that moment could have created tons of particles, added mass, and fueled this huge expansion. So instead of a big bang out of nowhere, we might have had a big bounce from inside a black hole. That would also explain why our universe looks so smooth and flat today. The theory goes even further. Thanks to torsion, every black hole might actually create a new baby universe inside it. And then, instead of black holes being dead ends, they might be wormholes, kind of like tunnels, connecting our universe to another one. And when stuff falls into a black hole in our universe, it might be popping out into a new universe on the other side. And in that new universe, our black hole would show up as a white hole, the exact opposite of a black hole. You can't go into it from the outside, but things can come out of it. But let's talk a bit more about those new James Webb findings. If our universe turns out to have a preferred axis, like a cosmic direction in which things tend to spin, that could indeed mean that our universe was born inside a black hole from another universe. You see, black holes form from stars, galaxy centers, or even tight star clusters called globular clusters. All of those things rotate, so when a black hole spins, any universe it creates inside might inherit that spin. Basically, the axis of rotation from the black hole could become the cosmic spin direction in the baby universe. However, there's another explanation for why the Webb telescope has seen so many galaxies rotating in one direction. And this explanation is that the Milky Way's own rotation could have caused it.
Mars has long been a source of mystery and fascination, with numerous anomalies discovered on its surface that challenge conventional explanations.
Among the most intriguing is a square-shaped formation captured by the Mars Global Surveyor's orbiter camera. This unusual structure, visible in an image available through Arizona State University's Mars Image Explorer, has sparked intense debate among researchers and enthusiasts alike. Many believe that this geometric formation, along with other peculiar structures on Mars, warrants further investigation as it could potentially reveal artificial or unknown processes shaping the Martian landscape. The discovery of this square-shaped formation has raised profound questions about its origin. Unlike the chaotic natural formations typically seen on Mars, this structure exhibits a level of symmetry and geometric precision rarely found in nature. Most natural geological processes, such as erosion and volcanic activity, tend to create irregular, unpredictable formations. However, the almost perfect angles and well-defined edges of this Martian square suggest that it may not be the product of ordinary geological forces. Some skeptics argue that its unique shape indicates an artificial or intelligently designed origin, pointing to the possibility that Mars may have once harbored an advanced civilization or been visited by extraterrestrial beings in the distant past. If this theory holds, the square formation could represent the remnants of an ancient structure, now partially buried under Martian dust and sediment. One of the most compelling aspects of this formation is its location and scale. The image from the Mars Global Surveyor provides detailed measurements suggesting that the square formation is significantly large, far beyond the scale of ordinary rock formations. Its distinct shape compared to the surrounding terrain makes it stand out as an anomaly, further adding to the mystery of its existence. If it were merely the result of natural geological processes, one would expect to see other similarly shaped formations nearby. Yet this is not the case. This discrepancy raises questions about whether Mars has undergone processes unknown to mainstream science, or if intelligent intervention played a role in shaping its surface. Supporters of the artificial structure hypothesis argue that the square formation could be a remnant of an ancient Martian civilization, similar to the ruins of ancient cities found on Earth. They suggest that if Mars once had conditions capable of supporting life, it is entirely plausible that an advanced society could have flourished there before some catastrophic event led to its demise. Given the evidence of past water activity and the possibility of an ancient atmosphere, this theory is not as far-fetched as it might seem. If Mars did indeed host intelligent life in the distant past, structures like the square formation could be key to understanding the history of the planet and the fate of its inhabitants. Another possibility is that the square formation may be linked to extraterrestrial visitors. Some researchers speculate that Mars may have been used as a base or an outpost by non-human intelligences at some point in history. The precision of the square shape and its distinct edges lend credibility to the idea that it may have been deliberately constructed rather than formed through random geological processes. If true, this would suggest that Mars has played a far more significant role in interstellar history than previously thought. NASA and other space agencies have largely remained silent on the implications of these formations, often dismissing them as natural rock formations or imaging artifacts. However, this stance has not deterred independent researchers and analysts from continuing to investigate. With the increasing availability of high-resolution images from Mars rovers and orbiters, more anomalies are being identified, adding to the growing body of evidence suggesting Mars may not be the barren, lifeless world it is often portrayed to be. The presence of geometric formations on Mars raises profound questions about our understanding of planetary science and history. If the square formation is indeed artificial, it could revolutionize our understanding of Mars and the possibility of extraterrestrial intelligence. Despite skepticism from mainstream scientific circles, the demand for further study of these formations continues to grow. Many argue that future missions to Mars should prioritize the exploration of these anomalies using advanced technology to determine whether they are truly artificial in nature. With human missions to Mars on the horizon, the opportunity to investigate these structures up close may soon become a reality. If we are to uncover the true nature of Mars, we must be open to the possibility that what we find there could change everything we thought we knew about the universe. the square-shaped formation on Mars remains one of the most intriguing and unexplained discoveries in planetary exploration. Its geometric precision and distinct appearance challenge traditional explanations and fuel speculation about its possible artificial origins. Whether it is evidence of an ancient civilization, a remnant of extraterrestrial visitors, or a geological anomaly unlike any seen before, this formation demands further study. As humanity continues to explore the cosmos, we may one day uncover the truth about Mars and the mysterious structures that lie on its surface, revealing secrets that have been hidden for millennia. Picture this. We finally make contact with aliens. Exciting, isn't it? But then comes the big question: how do you even start a conversation with beings who might be as different from us as apples are from algebra? Enter Olaf Witkowski with an idea that's, well, pretty out there. He thinks the best way to say hello to extraterrestrials is to threaten them. Here's his reasoning. No matter what kind of alien life form we're dealing with, whether those are slimy space blobs or super advanced warriors, there's one universal trait all life shares: the will to survive. It's the basic definition of life itself. His idea is to make them feel like their survival is under threat because, as he puts it, they'll understand that. Essentially, it's like tapping on a fish tank to see if the fish are awake, except these fish might be armed with laser beams. But hold on, this idea isn't about actually hurting anyone. Witkowski's whole point is that survival is a language that surpasses biology or culture. If aliens perceive us as a threat, it might actually open the door to showing them we're capable of cooperation too. Once we've got their attention, we might even find common ground in the basic instinct to stay alive. Sounds like nihilism to me. But before you start picturing Witkowski as some kind of evil sci-fi villain, let's clear that up. He's anything but. Think of him more like a philosopher meets scientist. Calm, introspective, and all about exploring ways to create understanding. He's traveled the world, mastered about a dozen languages, and dedicated his career to studying how AI systems cooperate. If anyone's got a shot at cracking the code of alien communication, it's this guy. Still, not everyone's convinced by his poke the aliens approach. For decades, scientists have been discussing the theory that math and physics could act as a universal language. The idea is that if we beam a signal containing something like prime numbers, the aliens would recognize it as intelligent. After all, a prime number is a prime number, whether you're in the Milky Way or Andromeda, right? Well, perhaps not. Carl Sagan, an American astronomer and planetary scientist, once tested this idea by handing a coded message to talented scientists at a party and asking them to decode it. Spoiler, they failed. And if humans can't crack a supposedly universal message, what makes us think aliens would? Then there's the old debate about whether we should even want to meet extraterrestrials in the first place. Many SETI aka Search for Extraterrestrial Intelligence researchers are optimistic, arguing that any civilization advanced enough to travel between stars must also be peaceful. After all, they'd need to have avoided destroying themselves to reach that point. Plus, let's face it, Earth probably doesn't have anything they can't find somewhere else in the galaxy. Mining our planet for resources when there are countless uninhabited planets out there just seems like bad economics. But not everyone's so sure. Some argue that the galaxy might still be a survival of the fittest kind of place, where the most aggressive civilizations end up on top. Even if most aliens are peaceful, who's to say there aren't a few space pirates out there looking for trouble? On the other hand, what if aliens aren't here to conquer us, but to study us? Maybe their way of reaching out is by testing our survival instincts, kind of like saying, hey, let's see what you're made of. To them, it might not seem hostile at all, a version of a handshake, even if it feels like a punch to us. So what do we do if that day ever comes? There's no perfect answer. Some scientists will keep sending out math problems into space hoping for a friendly reply. Others might be more open to riskier strategies like survival-based mind games. Either way, first contact is bound to be a scenario unlike anything we've ever faced. And if you were in charge, would you try Witkowski's approach and poke the alien bear to start a conversation? Or would you play it safe and hope they send us a "we come in peace" message first?
Titan is Saturn's largest moon. It's also the second largest moon in the solar system, after Jupiter and Ganymede. And it's the only moon with clouds and a dense planet-like atmosphere. But the coolest thing? This moon might help us understand how life appeared on Earth, and for us to understand whether you like such videos or not. Please put a like and subscribe to the channel. Your support is important to us. Thank you. Astronomers say that the conditions on Titan might be almost the same as those on Earth in its early years. The only significant difference is that, being closer to the Sun, Earth has always been warmer. Titan is surrounded by an orange haze, which had kept the moon's surface a mystery for astronomers up until 2004. That's when the Cassini mission arrived there. Now we know that Titan's atmosphere extends about 370 miles high. That's a lot higher than the atmosphere of our planet. Because of this atmosphere, Titan was believed to be the largest moon in the solar system for a long time. But the most exciting fact about Titan's atmosphere is that it's full of organic compounds. If they were discovered on our planet, they would definitely mean life. Now, the atmosphere of Titan is mostly nitrogen mixed with a bit of methane and other organic compounds, which form when sunlight destroys methane. But if sunlight keeps destroying methane, how does this gas appear in the atmosphere again and again? On Earth, it's life itself that restores the supply of methane, since it's a byproduct of the metabolism of many organisms. So, can we conclude there's life on Titan? This distant moon isn't the most pleasant place to settle down. It's too cold for liquid water to exist on its surface. And still, Titan has rivers, seas, and lakes of liquid hydrocarbons, such as methane and ethane. The largest of them are hundreds of feet deep and hundreds of miles wide. Beneath the thick crust of the moon, there is a more liquid ocean consisting primarily of water rather than methane. After a series of laboratory simulations, scientists concluded that there might be enough organic material on Titan for a chemical evolution to begin. It could be similar to the one that started life on Earth. But for that to happen, there must be liquid water on the moon for longer periods of time than what we observe now. And still, it might be another proof supporting the idea of a liquid water ocean under the frozen isolation layer. If it was true, Titan's subsurface ocean could turn out to be a place harboring life as we know it. Meanwhile, its lakes and seas of liquid hydrocarbons could have forms of life with different chemistry than what we're used to. Or there may be no life at all. After all, the temperature on the surface of Saturn's moon is about 290 OF. These conditions are far from comfortable for almost any life form. According to one theory, a meteorite impact that occurred a long time ago could have provided enough heat to liquefy water for around a few hundred or thousand years. But right now, most experts think that Titan isn't likely to be a place where life thrives, which makes the presence of methane in the moon's atmosphere even more puzzling. Interestingly, Titan might become warmer in the future. You see, 5 to 6 billion years from now, the sun will become a red giant. It will heat up most space objects in our solar system, and Titan will become warmer, 94 OF. This temperature is high enough for stable oceans of a water-ammonia mixture to exist on its surface. With time, the sun's ultraviolet output will decrease, which will enable the greenhouse effect in Titan's upper atmosphere. The combination of these conditions might exist for several 100 million years, creating an environment suitable for the appearance of exotic forms of life. After all, this time was enough for life to evolve on Earth. The only thing that might hinder the process on Titan could be the presence of ammonia. It's likely to cause the same chemical reactions to proceed more slowly.
Imagine traveling 10,000 years into the future. What would our planet look like? Would there be giant volcanoes? Would most of its surface be covered with oceans? And what if we traveled even farther, 1 billion years in the future? Now, Earth is about 4.5 billion years old, and when it formed, it looked very different from now. It was an extremely hot world, drowning in molten magma. Then, over the course of a few 100 million years, the planet began to cool. That's when the oceans filled with liquid water appeared on its surface. Heavy elements, initially floating on the surface of this bizarre Earth, started sinking past the oceans and magma toward the center of the planet. Earth became layered. The outermost layer was a solid covering made out of relatively light material, while the denser substances sank to the center of the planet. That's how it all began. Now, speaking about such a distant future, and 1 billion years is no joke, the chances that humans will still be around are very slim. You see, there are quite a lot of threats the human race might face in the process of its development. Climate change, overpopulation, falling asteroids and comets, ice ages, the sun getting hotter. Let's say you've got your hands on a time machine, and on your way to see what our planet will look like in 1 billion of years, you make a few stops. And the first one is 10,000 years into the future. One of the main changes is the appearance of people. Apparently, genetic differences are no longer regional. Such traits as skin tone or hair and eye color are evenly distributed around the globe. 20,000 into the future, and you don't understand people anymore. None of the current languages is recognizable, and the language people speak only has 1% of the present-day vocabulary. Moving further, 50,000 years into the future, and you realize with horror that a new ice age has started. Niagara Falls have eroded, and a day on Earth has increased by 1 second. Your next stop is 250,000 years from now. The landscape of the planet has changed a bit. For example, a new island has formed in Hawaii. After exiting your time machine 500,000 years into the future, you realize you might have made a mistake. Fires are raging all over the planet and the air is nearly unbreathable. The reason is a giant asteroid. People didn't manage to prevent it from hitting Earth. You hop into your time machine and set the timer to 1 million years from now. It seems you're out of luck. This time, it's a massive supervolcano eruption, spewing out hundreds of cubic miles of ash. It's already produced enough lava to fill 75% of the Grand Canyon. 2 million years into the future, and people have created settlements all over the solar system. Humans look different on different planets and moons since their bodies have adapted to particular conditions existing in those regions. 50 million years into the future, and you see that Earth is still changing. A massive part of Eastern Africa has broken off, forming a new ocean basin. Africa has crashed into Eurasia and closed off the Mediterranean Sea. A new mountain range, higher than Mount Everest, has formed between these two landmasses. Also, Mars has collided with its moon and got a cool ring system, just like Saturn. You make a stop 600 million years into the future and find out that a gamma-ray burst has occurred around 6,500 light-years away from Earth. Luckily, it hasn't hit our planet. Otherwise, there would no longer be the protective ozone layer and it would have caused a mass extinction. Also, the moon is now so far from Earth that there are no more total solar eclipses. And now, your final destination, Earth 1 billion years from now. With bated breath, you leave your time machine and freeze in shock. Our once beautiful planet has turned into a lifeless desert. The levels of carbon dioxide have dropped dramatically, and there's no photosynthesis anymore. It means that free oxygen and ozone have disappeared from the atmosphere, and there's no more complex life on the planet. Plus, the sun's luminosity has increased by 10%, making average temperatures on Earth rise at least twice. You feel as if you're standing in a giant damp greenhouse. The oceans have evaporated, leaving a few small pockets of water at the poles. What about people? You won't find them on Earth. By now, they have already colonized some faraway planets in faraway galaxies. You should probably leave this inhospitable world too.
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard, though, is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI Project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path. A white dwarf star, 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we miss the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around. Mars is the Earth's space cousin. It's the 4th planet in our solar system, about half the size of the Earth. It also has 2 small moon buddies, Phobos and Deimos. These moons are shaped like potatoes. Phobos is the drama king, moving closer to Mars and planning a crash landing in about 50 million years. Deimos is much calmer though, hanging out farther away from Mars. Mars got a cool nickname, the Red Planet, thanks to its rusty red surface. This color was so bright that it was spotted by astronomers many years ago. Even you can sometimes see it in the sky with the naked eye, a small scarlet dot. And maybe it has hot vibes, but in reality, Mars is a very cold desert. The temperatures there can drop as low as minus 240 degrees Fahrenheit. But was Mars always nothing more than a rusty-looking desert? Actually, no. Scientists believe that perhaps many years ago, this planet was similar to ours. Meet Curiosity, the detective rover made by NASA's Jet Propulsion Laboratory. Scientists want to know all about the Martian weather, landscape, and other stuff like that. Curiosity is a pretty heavy car-sized robot. It weighs about 1,985 pounds. It embarked on its journey on November 26, 2011. The rover pulled off a landing on Mars on August 6, 2012. Originally, Curiosity's mission was supposed to last for 2 years, but it's still going strong. Curiosity is basically a space lab on wheels. It's packed with cameras, spectrometers, radiation detectors, and sensors to sniff out the Martian environment. As Curiosity roams around, it rewinds Mars history. And during its mission, the rover discovered something incredible: signs of lakes and rivers from long ago. You see, Curiosity's favorite spot to play around is Gale Crater. It's a prehistoric Martian oasis where water might have hung out. There's this huge mountain in the middle called Mount Sharp. This place is taller than 10 Eiffel Towers stacked on top of each other. And it's got layers of rocks that hold Mars's ancient secrets. Recently, scientists spotted something great when studying Curiosity's data: mud tracks. What's so surprising about that? Well, these aren't just any old tracks. They're like messages from the past. They mean that the Martian ground used to get wet and then dry out again. The mud on the ground would shrink and crack during the drying phases, making these T-shaped junctions. Moreover, it seems like the ground on Mars went through several wet-dry cycles. It happened maybe up to 10 times. This made the junctions turn into Y-shaped cracks. When a bunch of Y-shaped cracks got together, they made a super cool pattern, something like a patchwork of hexagons. It looks just like honeycombs, or even a dragon's skin. Each of these hexagons are the size of candy. Similar cycles have happened on Earth, and they're linked to the birth of life. When water dries up, it leaves behind concentrated stuff that's great for chemical reactions, and these reactions might be the same ones that kickstart life. These hexagons have been hanging around for a really, really long time, billions of years. That means that Mars once had a climate kind of like Earth's, and maybe even life. In fact, the red planet even has some signs of water right now, in the form of hidden ice at the poles. Mars has the North and South poles, and just like with the Earth, they're red planet's ice caps. Picture the North Cap as a big, icy pancake about 620 miles wide. The South Cap is a bit smaller, about 220 miles wide, but it's got a thicker ice layer, almost like a snowball with a strong shell. When it's winter at the poles, it's an incredibly long nighttime. No sunlight, just chilly darkness. During that time, around 30% of the air turns into frozen CO2. It's dry ice, the same stuff that's often used in horror movies. But when the poles wake up to sunlight, the dry ice turns back into gas. All this freezing and thawing makes clouds and frost, just like on Earth. One time, a rover named Opportunity even caught some clouds made of water ice. But it doesn't necessarily mean Mars was once thriving just like the Earth. Life needs more than just wet, dry cycles to pop up. It needs the right atmosphere and other special ingredients. We're not sure if Mars had all of those, and even if it did, there's no guarantee that life actually happened. But this raises another very important question. Has Mars ever hosted tiny living creatures? Curiosity isn't the only robot that tries to find the answer to that. There's also a rover called Perseverance. It's trying to find clues about Martian life. It's digging into an old Martian crater once filled with water. And like a space archaeologist, Perseverance is searching for fossilized signs of ancient critters. And here's the funny thing. Some scientists think that we've stumbled upon it almost half a century ago. The only problem is, we might have accidentally destroyed it. It happened even before Curiosity started rolling around Mars. Back in the 1980s, two cool NASA's landers, Viking 1 and Viking 2, made a pit stop on the red planet. These landers took a selfie, and then they also did some funky experiments on the Martian soil, all in the name of finding signs of life. What they found is some weird organic stuff called perchlorate. It's a compound that we use in fireworks or rocket fuel. But most results didn't seem that promising. They even mixed up some soil with water and nutrients, hoping that if there were Martian microbes, they'd snack on the goodies and return radioactive gas as a result. But unfortunately, that didn't happen. Now, here's the problem. Some scientists think that maybe the water they added back then actually destroyed those tiny Martian critters. poor microbes were just hanging out and suddenly got soaked by a bunch of weird liquid. Something like this wouldn't be very pleasant for the Earth microbes. They live inside rocks and they're sucking water from the air. Pouring water on them would result in a total disaster. So, of course, giving them nutrients after that wouldn't do anything. If you've just barely survived a water bath, you're probably not in the mood for a feast. Perhaps these Martian buddies might have something called hydrogen peroxide in their cells. It helps them live in an extreme environment. If that's true, it could explain all the results from the experiments. You see, the instruments heated up the samples. So if there was hydrogen peroxide, it would have gone boom, wiping off the little guys and turning their cozy homes instantly. Imagine how ridiculous it would be if it turns out that we accidentally destroyed the only signs of life on Mars. Ideally, we need a new mission to Mars to test this theory. Let's hope it's not true. In any case, the journey isn't over. There are more missions planned for Mars, and humans might even visit this planet someday. The next mission is the Mars Sample Return. It's a super cool teamwork project between NASA and ESA. They're teaming up to bring back souvenirs from Mars, collected by NASA's trusty Mars Perseverance rover. There's going to be a whole bunch of spaceships. They'll work together to bring these precious Mars samples back. The samples are planned to arrive on Earth in the early to mid-2030s. And the fun doesn't stop at Mars. Our Mars missions are a warm-up for an even bigger adventure, exploring icy moons around Saturn and Jupiter. These moons have hidden oceans beneath their icy surfaces, and who knows what kinds of space secrets they're hiding. But whether it's Mars, icy moons, or beyond, our quest to find extraterrestrial life continues. In addition, we are slowly starting to find more and more organic materials on Mars, and maybe one day we'll finally find some microbes in our solar system. Let's hope for it and stay tuned.